Hello, I wanna express better in my Python code for Yetken job and Akbar data science and artificial intelligence training program project. Firstly, I should share my screen, all my screen, and I want to clarify what is the aim of the project shortly. 6 or 7 minutes, I guess. It's to explain and analyze better heart attack analysis and make some predictions and estimations about that. I mean, there exist several categories such as age, gender, blood pressure, cholesterol level, whether the people have higher fast blood sugar or lower fast blood sugar, or for pulses and pressures, all peak levels, which means I'm sorry, waves and fluctuations in the machine oscillators and their levels in Cartesian coordinate systems and so on. But surely we did not use all categories, we clustered that. First, start to examine that. First, we import necessary libraries, pandas, matplotlib, seaborn is not used, but I just imported that. SciPy to use in models and tests, NumPy to use several functions, and stats models. It's also used in linear regression models, and Skylearn linear model, train and split methods to start into machine learning with trained data, and so on. Firstly, we import our raw data from CSV file. Here it tries downloads. Also, you know that I just need to remind that the location is imported, so you might need to change that part to executing in your computers. And then check the info of data, whether what's the count, what are missing values, and so on. There exists no missing value in that data. I couldn't do complete a project in banking or finance sector because there are not enough data. We already covered good data sets in our lectures. So I choose that topic. And also, we need to detect and clean our outliers. Before that, we remove some of categories, which we not use that. So we only obtain the categories which we are going to use. And then we replace, 1, 0, 1, 2, 3, 4, 5, and kind of numbers. Although they are numbers, they are not numeric values. They are qualitative kind of data. There is no difference between them. We replace them. And we create a figure to see all box and whisker plots together. It's better to view that. And we create the plots for the numeric variables, such as age, blood pressure level, cholesterol level, TALAC level, and all peak score levels. And then we determine IQR. We'll use that approach to remove outliers, which is the difference between 75th percentile and 25th percentile of our data points. And upper bound and lower bound is determined depending on that. Finally, we remove data which is greater than our upper bound and less than lower bound, which means that you remove outliers also. And the new data is that we check the count decreases surely, but I did not remember exact number. We will cover that if we have enough time. And check the new box and whisker plots also, because maybe just to move in a more certain way. And firstly, we can start analyze by creating pivot tables, as I thought. And we inserted several pivot tables, which helps a lot in group data and analyze that. Firstly, we covered the pivot table of firstly, we group age and cholesterol levels, which has a high range to view that in one table, single table. So we group by 5, such as 29, 39, 39, 49 for age. So 179, 210, 19, and so on for cholesterol levels. And first pivot table is, although it writes FBS for that, the function is count. So it counts the people depending on age and sex, just to view how many people had heart attack in what age and gender groups. And second table is the average blood pressure, depending on the same groups also. And we continue like that for cholesterol levels, mean cholesterol levels, or resting blood pressure also. But we also get counts, so it does not mean anything. And also we get count depending on age groups and fasting blood sugar, whether it's greater than 120 milligram or less than that. Oh, 5 minutes also, but I need to continue. Sorry, I will pass 7 minutes a little bit. And so I just need to move a little faster, and we get column and bar charts, only bar charts, sorry, to view the counts and means, which are separate variables and appropriate to view in column or bar chart. After we get several informations with this analysis, we check histograms to use financial statistic methods because we have normality assumption. And then we check the histograms of all numeric variables in that. And also, we get probability plots, other name is QQ plots, because auto-histogram gives an idea. I check it, I just want to check it for different ways. And QQ plots also will be checked. Therefore, a parametric test is applied, which is Anderson-Darling test, to check the normality assumption of the data. And the test result is printed, they will be covered. And then it's seen that some of groups we can use t-test, hence we have normality assumption. I mean, the sample size is also greater than 35, but I thought that it will be better to use a t-test because it's an only sample. We don't know population standard deviation. Normally, we can estimate to use z-test, but if we know population standard deviation, but we don't know that. And also we don't know that underlying distribution is normal for these categories, and so on. And our hypothesis is, and can be assumed from 3 tables. Yes. Mean cholesterol level for female is greater than male. The mean of cholesterol levels for 2 gender groups are tested. And I thought that the people with higher fast blood sugar also are older people. So we test it depending on means again with t-test. And finally, all-peak score. I thought that if blood sugar level is higher, there exists more contraction in veins and in veins, and the pulse is higher. So all-peak score might fluctuate more and get higher mod points. So mean all-peak score for higher fast blood sugar is higher than low fast blood sugar levels. And then we group data to test them. And finally, hypothesis testing are applied, which is the test also in that example. And except mean all-peak scores, we can reject null hypothesis in 95% confidence level, which is a good thing. And we also want to check the correlation between variables, and we created its correlation tree. And after we do that, we thought that we can create a linear regression equation model. And we start to get X and Y variables, while blood pressure is dependent variable because it might be affected in the patient of heart attack by age, cholesterol levels, like old peak, CA, and toll, etc. Firstly, when we had constant, which I don't know where I written that, but yes, that part. When we had constant, our square value is too bad, so we removed constant and create the model again. And we see that toll and CA variables is not appropriate for that model because their t-test statistics are too bad, which we cannot reject null hypothesis about that. Individual beta values for that variables are different than 0, so it's forced to be 0. They are forced to be 0. Then they will be removed from our model. And new model, we removed that variables in our X variables, and we recreate the model again. Again, data 0, which is intercept value, is not added because our square value gets too bad. And finally, we get a adequate model in terms of statistics, but independence of error term assumption needs to be checked whether your linear regression equation estimation model is appropriate to create an annual weight. And so regression plots and some other plots are obtained in that part for different figures. Sorry. And then when we check that, we see that generally assumption is good, so we can create our linear model, and the model is that, which are individual beta values, while TRT with C are dependent variable. And also error exists, but expected of error term in our assumption is 0. So the model is without error like that, bilinear of expectation. And finally, we try to get an ML model, machine learning model, which until that part, we get a good linear regression equation model, which works our current data good. But in order to use it in the machine learning model, it also needs to be worked well in trained data and all data. So we use train and split method to in a 75% size. And finally get the model, but our square value is too bad. Hence our square value is too bad. We see that we get overfitted, and we need to check it needs to be improved by new data or some other techniques. Hence we overfitted. We cannot use in ML model, but we try to see the results. And let's run it in a few minutes only. Here are necessary tables. Data, its information, clean data, and so on. Our pivot tables need to be analyzed, but I cannot express deeper because of time. And Anderson-Turing tests and their results, significance levels and p-values depending on that critical values, where statistics is that, and so on. Summary of our linear regression equation estimation model, which is, we see that t-test of some statistics p-value are high, which are CAA and SOL. And also it's given in the notes of that package. And also we do not add constant, as you see. And new model, we see that all p-values are appropriate to reject null hypothesis, which states the being 0 for the individual beta values for that variables, and we can reject them. And finally, we start train and split model. Although the statistics is very, very good, our square value, which is here, is perfect. I mean, the score of the model, I mean, sorry for that, that's the last model, but statistics are good, but the score of our ML model, which is created by train and split method, is negative, which means that we get better results if we just draw a straight line. So we cannot use that model. We overfitted to our data, and we check it by inferential statistics, data science, and machine learning methods. Thanks all for what you learned, what you taught to us. Have a good day. And also pivots, as you see. Regression plots and some other plots. Correlation heat map, QQ plots, histograms, count bar charts and mean bar charts for which are estimated by pivot tables. Outliers, which is the, I just close second box plot, but which is the first box plot, and we can see outliers clearly for these categories, and so on. Thanks for your time and consideration.